with Azure machine learning. So, all right, so we go on to it. So the Microsoft um, learning sites has everything you need to pass the DP 100 exam. And all you have to do is go through them carefully. And when you go through them, you're able to see, like when you click on the link, you get to the screen. Each of the parts are listed. Manage and review models in Azure machine learning. You can open up the tab to see what follows under. Introduction, log models with MLflow, understand the MLflow model format, register an MLflow model. So we're going to follow through this, and I might beat fast because of time, so we can cover ground. Then we're also going to go through create and explore a responsible AI dashboard for a model in Azure machine learning. We also collapse, we can open this up as well. We're going to go through all this. Then when we are done with this, we still have 2 more modules to go through. So stay with me now as we move on to the introduction. So the learning objectives is actually about logging models with MLflow, understand the ML model format, register an MLflow model in Azure machine learning. I'm not sure how vast a lot of us are, but there are certain skills that are needed as a data scientist and to understand the machine learning components. Like when we talk about ML flow, um, it's, it's for you to be able to understand as a data scientist, you're going to have to be able to register your workflow of the, uh, sorry, but let's just read through this first. After training, you want to deploy a machine learning model in order to integrate the model with an application. In Azure Machine Learning, you can easily deploy a model to a batch or online endpoint when you register the model with MLflow. The example given here is about a data scientist working for a company that creates an application for health practitioners. The practitioner wants to input as in data and get a response from the application, indicating whether a patient is likely to have diabetes or not. So what happens normally is when a patient comes in, the patient tells the medical practitioner that I have certain issues. So the medical practitioner is supposed to get that information, put it into the application, and have the application, give it back feedback. So how it does this is that it goes in every time the model is retrained. You want to update the model that is deployed to the endpoint and integrated with the application. By doing so, you're providing practitioners with the latest version of the model anytime they use the application. What that simply means is that anytime the practitioner puts in the client's details, immediately the information there is being sent to an endpoint, and endpoint then retrains what you already have to make it better and sends it back. You will learn how to register a model with MLflow in Azure Machine Learning to prepare the model for deployment. What I'm trying to do is trying to break it down in simple terms than just the technical terms. Is that so when you can imagine what is going on, be able to understand better than just if I were to tell you all the technical parts, which you can read on your own, which is already here. So I hope sorry, it's my first time tutoring live, or I usually do it face-to-face to see the reaction of my students. But let's see how it goes. So the main objective is to understand that we are trying to understand how we deploy MLflow to help our system with an Azure machine learning platform. And so, yeah, let's just go on with it. This is just the beginning parts. To train a machine learning model, you may choose to use an open source framework that best suits your needs after training. You want to deploy your model. MLflow is an open source platform that streamlines machine learning deployment, regardless of the type of model you trained and the framework you use. MLflow is integrated with Azure Machine Learning. The integration with Azure Machine Learning allows you to easily deploy models that you train and track with MLflow. For example, when you have an MLflow model, you can opt for the no-code deployment in Azure Machine Learning. So basically what's saying here is that as a data scientist, your major skill is being able to use code as well. But Azure Machine Learning has allowed a no-code deployment avenue for people that cannot code. And most people rather opt for that. But there's a reason why you, as a data scientist, need to understand why you understand the coding environment, the Python SDK, and the CLI. There's a reason why you need to understand that. If at all you're not very good at writing code, you still need to be able to read the Python scripts that are being pushed out so that when you see them, you are able to troubleshoot to know when an error comes in. Because right now we are living in the world of AI. Everything you can just drop into the AI and AI tells you what to do. But in as much as you have AI to do that, AI itself has some challenges. You as a data scientist need to be able to understand what these Python codes are saying and what they're actually doing. So that's what we're going to be going through. We're going to be going through of course, what Azure Machine Learning has helped us to do easy in a no-code deployment environment, but you should also be able to understand in the Python SDK and CLI environment, although more emphasis on the Python SDK than the CLI. There's a note here. So anytime you open Microsoft Learn and you're going through the curriculum, you notice they always give you some notes. They are for you to learn extra reading. Like this particular one is good for you to click on, but I'm not going to click on it here for you. You can always go back to check on this. Additional reading helps you understand things better. Why use MLflow? When you train a machine learning model with Azure Machine Learning, you can use MLflow to register your models. MLflow standardizes the packaging of models, which means that an MLflow model can easily be imported or exported across different workflows. For example, imagine training a model in an Azure Machine Learning workspace used for development. If you want to export the model to another workspace used for production, you can use an MLflow model to easily do so. When you train and log a model, you store all relevant artifacts in a directory. When you register the model, an ML model file is created in that directory. The ML model file contains the model's metadata, which allows for model traceability. And you can register models with MLflow by enabling auto login or by using custom login. So for those of us that are familiar with the word metadata, this happens if you're using the normal computer. Anytime you create a file in your normal computer, a metadata has information regarding what that file is. In your machine learning environment and the ML model we're going to deploy, exactly what we're talking about is this metadata. But there are some technical jargons that we use, and you also need to be familiar yourself with them. When you register the model, an ML model file is created in that directory. The ML model file contains the model's metadata, which allows for model traceability, meaning for anyone that opens up that file, the person can understand certain things, and those things are usually put into these log files. And that's what they're just talking about here. Remember what I said about noting? When you see the notes, there are other extra things for you to understand. What the difference between an artifact and the model is. You can always read up on that later. Use autologging to log a model. When you train a model, you can include mlflow.autolog to enable autologging. MLflow autologging automatically logs parameters, metrics, artifacts, and the model you train. The model is logged with the .fit method is called. The framework you use to train your model is identified and included as the flavor of your model. Optionally, you can specify which flavor you want your model to be identified as by using MLflow. Now, this is just showing you the code like I mentioned earlier. As a Pythonista, you're supposed to understand when you see certain things like this, what they're telling you is that the flavor is a variable. There are different types of flavors. And what this flavor simply means are different models that they're open source that you can also use with the Azure machine learning environment. Um, some common flavors that you can use with auto logging are Keras, scikit-learn, LightGBM, XGBoost, TensorFlow, PyTorch, Onyx. Notice this TensorFlow and PyTorch. I think we've touched on it before. They are usually used for deep learning, but see how they are also used in with the MLflow flavor. Notice, like I said, the flavor is the variable. And for Keras, they replaced it with Keras, scikit-learn, sklearn, LightGBM. Notice all this. That's just what's going on here for you to understand and read the code. Because, like I said, you can use it as with the no-code deployment, but it's always good to understand what's going on with the codes. When you use auto-login, an output folder is created, which includes all necessary model artifacts, including the LML model file that references this file and includes the model's metadata. Like I said before, but we'll touch more about that later. When you want to have more control over how the model is logged, you can use auto log for your parameters, metrics, and other artifacts, and set log model equals false if you want to manually log a model. You have to understand this code to put in there so that you can manually log your model. MLflow doesn't automatically log the model, and you can add it manually. So there are certain reasons why you might want to do this manually. Like I said, there's the easy way without all the having MLflow auto log. You don't need to bother yourself much about it. But then you also need to understand how to do it manually. So basically, one of the ways you can learn this thing is not to think I'm just a beginner, I can't learn this thing. It's for you to calm down and say, like, okay, what are the easy way? What's the hard way? Everybody can do the easy way, but not many people can do the hard way. For you to be the data scientist that's own your skill, you've got to understand how this thing works, not just doing the automatic, learn how to do it manually as well. So there are certain reasons why you want to do this. As logging the model allows you to easily deploy the model, you may want to customize the model's expected inputs and outputs. The schemas of the expected inputs and outputs are defined at the signature in the ML model file. If you deploy a model and the inputs don't match the defined schema in the signature, you may encounter errors. Therefore, you may want to customize the signature to alter the deployed model's behavior, because it's wanting to send and set up your model and all, but once you encounter errors, are you able to troubleshoot? And one of the ways you can do that is when you manually log a model, is for you to understand it. So those are the reasons, like, why do I have to suffer myself to learn all these things? It's because nobody's going to be there with you when troubleshoots happens. You need to be able to know what went wrong and how to go about correcting it. Customizing the signature. The model signature defines the schema of the model's inputs and outputs. The signature is stored in a JSON format in the ML model file, together with other metadata of the model. The model signature can be inferred from datasets or created manually by hand. Log a model with a signature that is inferred from your training dataset and model predictions. You can use infer signature. For example, the following example takes the training dataset to infer the schema of the inputs and the model's predictions to infer the schema of the outputs. So like I said, it's important to understand the codes because I won't dwell too much about them because you can always go back to learn by yourself. But what I'm going to try to do is to break it down for you so that in your own spare time, you realize when you see code, you should not run from code. In fact, some of the best questions you get in the DP 100 are code questions because for that one, you're sure that you know the correct answer. The difficult ones are the ones that will ask you English questions that you start wondering, what are they talking about? But with code, you can't go wrong if you can understand what is going on. So what they're telling you here is that there's a need for you to know how to customize the signature and why you need to manually load the model. And this is like the code that needs to happen when you want to do that. So they tell you to import pandas. You already know what pandas is. sklearn. From the assemble import random forest classifier. I'm sure some of you are wondering, what is this? Some of you already know what a classifier does. So like when you're talking about trees, you're not doing linear regression. You're talking about trees and stuff like that. So all these things are important, but just understand why they're doing this. So you're importing this, you're going to need it. You're importing this MLflow, mlflow.sklearn. From MLflow, import infer signature. Then you follow through the data set. There was an iris data set. We we had practiced in the past. So this is a continuation from that on how to use that. So if you go through it, you're able to understand what is really going on here and why they are using all this code line by line. Don't let it push you or get you scared. Just try and, if you can read it at least, you're better off than just like giving up. Try to understand what the codes are saying and why. Also, note any of these green tags with the hashtag is the code to explain what's actually going on under the code. Infer the signature from the training data set and model's prediction. Signature is equals to infer signature. Iris string predicts iris string. Then hashtag again, log the scikit-learn model with a custom signature. So understand what's going on here, but because of time, we'll skip the codes now and we'll just keep jumping forward until maybe we hit somewhere that we might need to come back to. Learn more about logging MLflow model signature. Okay, so this model signature is important. Why? Because part of the files that are going to be logged in, you need to know what inputs and outputs are. So there are some types of, or let me just show you what these flavors are. Like I told you earlier on, there is the MLflow different flavors that come in. So I actually saved the screenshot to explain, but because of time, but let me just show it briefly. How do I share this now? This. Okay, it's this. Okay, I don't want to really touch on this. You will find them in the Microsoft Learn if you go through them. There are different other ones. And as we go on, you'll be able to see that all these model flavors, you can always use them. And that's why MLflow is actually one of the good things to use. It allows you to use all these things within the Azure machine learning environment. So because of time, I don't want to touch too much on that. So we just go back to where we are. And yeah, go on to the next. Understand the MLflow model format. MLflow uses the ML model format to store all relevant model assets in a folder or directory. One essential file in the directory is the ML model file. The ML model file is the single source of truth about how the model should be loaded and used. The ML model file may include artifact paths. During the training job, the model is logged to this part. Flavor, like I showed you in the previous slide, the machine learning library with which the model was created. Model UUID, the unique identifier of the registered model. One ID, the unique identifier of job one during which the model was created. Signature, specifies the schema of the model's input and output. Like I mentioned earlier, you need to know this. These are kind of the most important things in this file. Well, not the most, but you need to understand why. The inputs are valid inputs to the model, for example, a subset of the training data set. The output, a valid model output, for example, model predictions for the input data set. So I need you guys, I can't see the chat right now, but for you to do the test with me, can you tell, looking at this code, put in the chat, even though I can't see the chat, I'm sure my co-hosts will be able to see it. It's for your own good to try and see if you can read this chat. Out of all of these things we listed here, the artifact part, the flavor, the model UID, one ID, signature, input, output, can you tell what flavor is? Which one is the flavor? And with this code, can you tell the flavor from this code? So you put in the chat. I can't see the chat, but I'm sure Tejimola can see the chat. And it's for your own good. If you can read this code, it's a way to test whether you're going along. Can you tell which one of this has the flavor being specified there? Because you can see the artifact part, the classifier. You can see the model UUID, right? Where is that? That's the model UUID. The run ID is down here. Signature inputs and outputs is all right here. So did you guess correctly what the flavor is? The most important things to set are the flavor and the signature. And for those wondering what that flavor was, yes, it's fast AI. Like if you had noticed what I shared earlier on in the past, it's among the flavors. If you scroll down, there's fast AI here. So I hope some of you got it, and I hope you guys are following along. And that's why I said, you guys try to understand the code. Don't let them scare you. Don't let the code scare you. It's just for you to understand. Oh, okay, this is what they're saying here. This is what they need. This is the fast AI version. This is the Python function. But it's all stored in a YAML file. And yes, but like I said, let's not stay too much on the code. You can always go through this and understand them by yourself. My aim is for you to, at least after this class, to be able to have a bit of more confidence to do these things by yourself. So choose the flavor. A flavor is the machine learning library with which the model was created. For example, to create an image classification model to detect breast cancer, you're using Fast AI. Fast AI is a flavor in MLflow that tells you how a model should be persisted and loaded, because each model flavor indicates how they want to persist and load models. The ML model format doesn't enforce a single serialization mechanism that all the models need to support. Such a decision allows each flavor to use the methods that provide the best performance or best support according to their best policies, without compromising compatibility with the ML model standard. Python function flavor is the default model interface for models created from an MLflow run. Any MLflow Python model can be loaded as a Python function model, which allows for workflows like deployment to work with any Python model, regardless of which framework was used to produce the model. This interoperability is immensely powerful as it reduces the time to operationalize in multiple environments. An example of the Python function flavor may look like artifact pack, pipeline, conda, YAML file, virtual environment, loader module, model path, pickle file, predict function. So like I said, don't let the code scare you. Just go through them and know why they're being used. And of course, like I said, notice the signature, very important, input, output. So like the three most important things here are our flavor and signature, input, output. You will know why later, because there are some questions I will ask you at the end and you might want to remember that. Configure the signature. Apart from flavors, the ML model file also contains signatures that serve as data contracts between the model and the server running your model. There are two types of signatures: column-based, used for tabular data with the pandas.data frame as inputs; tensor-based, used for n-dimensional arrays or tensors, often used for unstructured data like text or images, with NumPy and ND arrays as inputs. As the ML model file is created when you register the model, the signature also is created when you register the model. When you enable MLflow's auto login, the signature is inferred in the best effort way. If you want the signature to be different, you need to manually log the model. Remember, we talked about manually logging. One of the reasons why you want to do that, if you want the signature to be different, you need to manually log the model. The signature's inputs and outputs are important when deploying your model. When you use Azure Machine Learning's no-code deployment for ML models, the inputs and outputs set in the signature will be enforced. In other words, when you send data to a deployed MLflow model, the expected inputs and outputs need to match the schema as defined in the signature. And for more reading, you could check out this as well in your spare time. Register an MLflow model. In Azure Machine Learning model, models are trained in jobs. When you want to find models artifacts, you can find it in the jobs output to more easily manage your models. You can also store a model in the Azure Machine Learning model registry. The model registry makes it easy to organize and keep track of your trained models. When you register a model, you store and version a model in the workplace. Registered models are identified by name and version. Each time you register a model within the same name as an existing one, the registry increments the version. You can also add more metadata tags to more easily search for a specific model. There are three types of models you can register: the MLflow, model trained and tracked with MLflow, recommended for standard use cases; custom, model type with a custom standard not currently supported by Azure Machine Learning; and the Triton, model type for deep learning workloads, commonly used for TensorFlow and Python model deployments. Azure machine learning integrates well with MLflow, which is why it's the best practice to log and register an MLflow model. Working with MLflow models makes model management and deployment in Azure machine learning easier. During deployment, for example, the environment and scoring script is created for you when using an MLflow model. Register an MLflow model. To register an MLflow model, you can use the Studio, the Azure CLI, or the Python SDK. Remember I mentioned this earlier on, and why you might need to focus on this guy as well, even though you can use the Studio with little or no code. As a data scientist, you may be more comfortable working with the Python SDK. To train the model, you can submit a training script as a command job by using the following code. So now they're showing you like how to register to train the model. This is the script that you do. And like I said, try to understand how these codes work. Don't let it scare you, but understand exactly what's going on in there. Command Python train model signature.py, training data diabetes.dsv file. Environment, when Emmanuel showed us the workspace, some of the places you see is when you select your virtual machines and stuff and environment. But now we are doing that using code. The cluster and everything, we're using code to create it. And as a data scientist, that's why the Python SDK is our preferred choice for you to be able to do this in code. I remember what I told you about the hashtags. They're explaining what's going on. Configure your job. This is what's going on here. You submit your job, return job. Note this code. Some of the questions you get in your DP 100 also relate to you understanding how to, create or update a job. How do you write it? ML client or create or update job. AM URL, return job, sub studio. Monitor, then print, monitor your job at AM URL. Once the job is completed, model is trained. Use the job name to find the job run and register the model from its outputs. Then, we go down here again. And like I said, I want you to not just get through the technical but understand why we're doing this. Okay. On comment after adding required details above, still you to know why we are using this. So all these things are important for you to remember and see and understand why we are doing it. The part, the name, the description, and the type. So we're at the end of this particular unit, but before we close this, I think I would like to ask for us. Okay, because I didn't prepare on time. Let's keep it. I was going to ask you some questions, but let's just go on to the next one because of time. All right, so we're on to the next part. Remember, we started from manage and review models in Azure machine learning and register an MLflow model in Azure machine learning. So we're on to create and explore the responsible AI dashboard for model in Azure. Let's go back there. All right, so we're in create, right? Close that. All right, when you train a machine learning model, you may experiment with multiple models to find the one that best fits your data. To compare and evaluate models, you can review relevant performance metrics next to the performance metrics. You should also review whether your models conform to responsible artificial intelligence principles. Responsible AI is an approach to developing, assessing, and deploying models in a safe, trustworthy, and ethical way. To help you with implementing responsible AI, Azure Machine Learning offers a responsible AI dashboard. You can create and customize the responsible AI dashboard to explore your data and model. Now, understanding responsible AI. As a data scientist, you may train a machine learning model to predict whether someone is able to pay back a loan or whether a candidate is suitable for a job vacancy. As models are often used when making decisions, it's important that the models are unbiased and transparent. Whatever you use a model for, you should consider the responsible artificial intelligence, responsible AI principles. Depending on the use case, you may focus on specific principles. Nevertheless, it's the best practice to consider all principles to ensure you're addressing any issues the model may have. Microsoft has listed 5 responsible AI principles: fairness and inclusiveness. Models should treat everyone fairly and avoid different treatment for similar groups. Reliability and safety. Models should be reliable, safe, and consistent. You want a model to operate as intended, handle unexpected situations well, and resist harmful manipulation. Privacy and security. Be transparent about data collection, use, and storage to empower individuals with control over their data. Read data with care to ensure an individual privacy. Transparency. When models influence important decisions that affect people's lives, people need to understand how those decisions were made and how the model works. Accountability. Take accountability for decisions that models may influence and maintain human control. So this section is kind of straightforward, but one thing you should take away from this is that responsible AI is actually a big industry that is going to explode currently in this new era that we're in AI, in artificial intelligence. So some of us that don't really like coding as much, you might want to pay close attention to this field as a branch in machine learning field to become for big companies that are looking for people that understand responsible AI. So it seems like, oh, what's there now? It's just not fairness and inclusiveness, reliability and safety. We've been doing that before now. Privacy and security, transparency, accountability. Yes, but there are deeper things that come up when you talk about ethics in AI. Currently, there are a lot of models that are being used out there. And one of my core strong points is generative AI. I first stumbled on AI, generative AI before I found DSM. And there are some models that are available for free, and some you have to pay for, and some you can pay for some premium features. But not to mention any names, there are some current ones that they are not transparent about how they train their data sets. And I'm talking about text to image generation. I don't want to mention names, but I know some of you might already have an idea of the ones I'm talking about. So they generate images, but people aren't aware of how they train those data sets. So there are other ones that tell you exactly how they do that. So those ones that tell you how they do that, they are following this particular code of transparency. Where models influence important decisions that affect people's lives, people need to understand how those decisions were made and how the model works. What happens when you as a responsible AI engineer is that if you're needed in any organization and you're able to explain to them why they need to adhere to these guidelines, you're going to be saving them millions of dollars in the future, because it will save you from lawsuits, to save you from people not trusting your agenda. And in long run, you are going to win over those that do not respect certain ethics. So pay close attention to this. And even in the DP100, there are some of the questions that do rely on this, on your understanding what all this entails. So, but not to take too much time on this, we can always come back to it. Let us go through the other slides that we have here. Where do we go? I have a little bit challenge navigating this. I don't want to stop sharing, but it's not allowing me to. Okay, here we go. All right, create the responsible AI dashboard. To help you implement the responsible artificial intelligence, responsible AI principles in Azure machine learning, you can create the responsible AI dashboard. The responsible AI dashboard allows you to pick and choose insights you need to evaluate whether your model is safe, trustworthy, and ethical. Azure machine learning has built-in components that can generate responsible AI insights for you. The insights are then gathered in an interactive dashboard for you to explore. You can also, the responsible AI dashboard allows you to pick and choose insights you need to evaluate whether your model is safe, trustworthy, and ethical. Azure machine learning has built-in components that can generate responsible AI insights for you. The insights are then gathered in an interactive dashboard for you to explore. You can also generate a scorecard as PDF to easily share insights with your colleagues to evaluate your models. Create a responsible AI dashboard. To create a responsible AI or RAI dashboard, you need to create a pipeline by using the built-in components. The pipeline should start with the RAI Insights dashboard constructor, include one of the RAI 2 components, end with gather RAI Insights dashboard to collect all insights into one dashboard. Optionally, you can also add the gather RAI Insights scorecard at the end of your pipeline. All right, so what are they talking about? What are they talking about here? In the Azure machine learning environment, when you're creating this dashboard, it's more like a drag and drop. You start first and foremost with this RAI Insights dashboard constructor. That's your first drag and drop file folder. Okay, I think I can even show you where that is. I think that's it. All right. Yes, I think we can use this. Yes. So this is your RAI Insight dashboard constructor. This one right here. So what they're telling you about from up here is that where we start with the RAI Insight dashboard constructor. The first part you start with is that box I just showed you. Then include one of the RAI 2 components, and with the gather RAI Insights dashboards, collect all insights into one dashboard. Optionally, you can also add the gather RAI Insights scorecard at the end of your pipeline. This is what we're talking about over there. So don't let all this confuse you. I'll still get here and explain more about how all this is going. What they're just trying to explain to you is that when you want a pipeline shows you from beginning, middle, end. It shows you in a diagram how everything is put together and what's going on. So don't let all the lines and everything look scary for you. Just try and follow ahead. You will understand it by the time I get to this part. But I just want to show you all this to try and explain what the dashboard looks like and why you need to configure certain things and what you need to start with. So going back up again. So that's to create a responsible dashboard, you need to create a pipeline by using the built-in components. Pipeline should, 1, start with this, 2, include one of the RAI 2 components, 3, end with this, and 4, optionally, scorecard at the end of your pipeline. Explore the responsible AI components. The available 2 components and insights you can use are add explanation to RAI Insights dashboards. This interprets models by generating explanations. Explanations show how much features influence the prediction. Add a causal to RAI Insights dashboard. Use historical data to view the causal effects of features on outcomes. Add counterfactuals to RAI Insights dashboard. Explore how a change in input will change the model's output. Add error analysis to RAI Insights dashboard. Explore the distribution of your data and identify erroneous subgroups of data. What are they saying in all this? There's a joke that is usually spread around among statisticians when you are gathering data and trying to talk about causation, that causation is not the same as correlation. So the inside joke is that a lot of people will say, because certain thing is this, certain thing is this, therefore it's this. But most times, just because something are correlated, it does not mean that they are causality. What is causality? The law of causality simply talks about cause and effect. Simple English of what the big grammar they try to confuse us with sometimes is that what caused something to happen? Are you sure it's exactly this? Or are we just assuming based on correlation? So to try and understand how our data lives up to the responsible AI itself, we need to be able to add all these certain things to our model so that, like the explanation to the area insight that this one interprets insights that we might have missed. It shows how much the features influence the prediction of our outcome. The causal, more of the cause and effect. Use historical data to view the causal effects of features on outcomes so that we're able to tell really what's going on. The counterfactual talks about when you change the input, how much does it affect the output? The error analysis, as the name implies, explores the distribution of your data and identify erroneous subgroups of data. All of this are still part of the diagram we'll get to. You can see the error analysis over here. You can see the explanation to area insights. So when we're talking about all things, they all come in together to fill in over here. But like I said, we'll still get down there. I just want to show you ahead so that you don't think we're just speaking another language. So yeah, build and run the pipeline to create responsible AI dashboard. To create the responsible AI dashboard, you build the pipeline with the components you selected. When you run the pipeline, a responsible dashboard and scorecard is generated and associated with your model. After you've trained and registered the model in the Azure machine learning workspace, you can create a responsible AI dashboard in 3 ways. Using the command line interface, extension for Azure machine learning, use the Python software development kit, this SDK that we're always talking about, using the Azure machine learning studio for a no-code experience. I've already overemphasized why we need to understand this particular one, and I don't want to plug it anymore. So using the Python SDK to build and run the pipeline, to generate a responsible AI dashboard, you need to register the training and test data set as ML tables data assets. Register the model, retrieve the built-in components you want to use, build the pipeline, run the pipeline. If you want to build the pipeline using the Python SDK, you first have to retrieve the components you want to use. You should start the pipeline with the REI Insights Dashboard Constructor component. So almost like all the things we said we needed here, now we're going to do them using our almighty Python SDK. And like I said, don't let the code scare you. Try and understand what they're saying and why we are using them. You should start the pipeline with the REI Insights Dashboard Constructor component. And here we go. REI Constructor component, ML client registry.components.get. Name, Microsoft Azure ML REI Tabular Insight Constructor. Label, latest. If you've read it, you understand it, just keep it moving. Then you can add any of the available insights, like the explanations, by retrieving the add explanation to REI Insight Dashboard component. So we are building from, first we started with this. Now our code, we're going to add explanation to REI Insights Dashboard component. REI explanation component equals ML client registry.components.get. Name, Microsoft Azure ML REI tabular explanation. Label, latest. So what's the difference between these two? If you look carefully, we just repeated the same one on top, same name, right? What changed? Tabular explanation. And what do we need table and explanation for? We're adding the explanation to REI Insights dashboard component. So like I said, understand why, and then your home run. All right, understand the code, and you'll be well on your way to go. And then, like I said before, always check back on these notes in your spare time. There are a lot of things you will learn from in there, but because of trying to reach what we are doing, if you have time, you can still come back and check all this. But I want us to really, at the end of the day, know that on my own, I can do this thing, no shaking. All right. So going on to this, and finally, our pipeline should end with gather area insights dashboard component. Remember what we did above again, right? What has changed? REI gather component, explanation component, constructor component. I forgot to mention that part. So notice little changes that are coming in there. Gather component, ML client registry.components.get. Name, Microsoft Azure ML REI Tabula inside gather label latest. Notice what has changed and know why we're adding it. Once you have the components, you can build the pipeline. So when you talk about components, you talk about pipeline. So those are terms like we could throw around, but just think about, I don't know, how many of you played Lego when you're growing up? Lego bricks. You can just have different components, but then putting them all together is the pipeline. Or what else can I do? Maybe you have a socket that you break apart. The final product is the socket itself, but everything that came together are different components. So what we have, this is a component, maybe the screw, maybe a plug, maybe something, and then all of them all together gives us the pipeline. So once you have the components, you can build the pipeline. And more code. For those of you that run away from code, you've got to be happy when you see code. Like I told you, when the questions come, your friends are this code. So if you understand this code, you'll be happy, you'll be smiling to the bank when you're writing your DP100. From Azure AI.ml, import input DSL. From Azure AI.ml.constant, import asset types. Add DSL pipeline, compute AML cluster. Experiment name, create REI dashboard. Define REI decision pipeline. Target column name, train data, test data. Notice our hashtags. What's happening here? We're initiating the REI insights. So create REI job, REI constructor components. Tied to REI dashboard diabetes. Tax type, classification. Model info, expected model ID. Model input type, asset type, .ml flow model. Path, Azure ML model ID. Train data set, train data. Test data set, test data. Target column name, predictions. So create REI job set, limit timeout 30. So we've initiated the REI insights. Now we're adding the explanations. Explanation job, REI explanation components. REI insight dashboards. Create REI job.outputs.REI insight dashboard. Comment, add explanation. Explanation job.set limit timeout 10. Then put everything together, combine everything. REI gather job, REI gather component. Constructor create REI job.output.REI inside dashboard. Inside explanation job.output.explanation. So what's going on in here? Like I said, try and understand and look at what's going on. We first started with initiate, then we added explanations, and then we combined everything. What are we combining? We are combining the create REI job.output.REI insight dashboard with the explanation job.output explanation. So still spend more time when you go back in your own free time. Try and understand what's going on. Because like I said, being able to read in Python is a super skill. we watch superhero movies. Everybody's always talking about Superman, Batman, and all those superheroes. But the real superheroes in our modern day now are people that understand code. And you guys on this call are the superheroes if you can understand this thing. So learn to harness your superpower. Don't run from it. Learn to harness it. So go back in your spare time, read the codes. And then we're back to the AI dashboard. After building the pipeline, you need to run it to generate the responsible AI dashboard. When the pipeline is successfully completed, you can select to view the responsible AI dashboard from the pipeline overview. So now, in this image, some of you were running away from before. I'm sure a lot of things are becoming more clearer for you now. Okay, so make sure you type DSM for this opportunity because when I was doing it by myself, everything seemed like Greek. But now, as in, that's the benefit of doing it together as a group is that you get to see from my own side of view of how I was able to navigate this everything. How I used to can, from my own, so I. So we talked about this area inside dashboard constructor a lot, all right? But keep in mind, this is where we're starting from, yes? But we've got to feed it with information. So follow these arrows, right? This diabetes that you see listed here is the data we have for the medical practitioner that we were talking about initially. And they have this data set, right? And we have you understand, I don't know, I think Emmanuel must have put you through all to explain what training data set is and a test data set is, where you are configuring your model and setting up. You need to set aside a particular amount of the data set for training, and usually a huge chunk, probably 80 to 90% of your data for training, and maybe the remaining 10 for testing, right? That's what's just going on right here. That's all what's going on. They're telling you that your model is, there's a pipeline flowing to the area inside dashboard constructor right here. And that arrow is showing you what's going on. What's going on. Everything's being fed into your area inside dashboard constructor. From that area inside constructor, we are also having our error analysis right here. What happens is, follow the arrows. The arrow is showing you what comes in. So we have our data set fed in, we train it, everything goes in here. We test it to find out what's going on. And then when all that is cooked in, the error analysis shows us that, oh, wait, is everything okay here or not? It now passes it down to get us more insights. It also, apart from the error analysis, we also have the explanation of what's going on with this full analysis. Break it down for us, the explanation. That's all what this diagram is showing us. But all the things we talked about, the error analysis, explanation, and gather area insight, we already talked about it all up here. Even when we were talking code, we're all inside there. The area dashboard diabetes, everything we talked about, they're all in here. And as we said, if you go all the way back here, they're also up here. So they are the main things we talked about here. That's all what's being reflected in here. So don't let the pipeline scare you, but this is how you build it. You build it knowing what's coming in, what's going out, and why they're there. Your training data, your test data, your data set, the error analysis, your explanation, and the insights dashboard that you gather, which they say is also optional, but the more the merrier to get more information. Alternative, you can find the responsible AI dashboard in the responsible AI tab of the registered model. So there are different ways you can find all this, right? So they're just showing you where we can find them in the Azure machine learning interface. And that's what's going on here, showing us where we can find them. All right, so evaluate the responsible AI dashboard. When your responsible AI dashboard is generated, you can explore its content in the Azure Machine Learning Studio to evaluate your model. When you open the responsible AI dashboard, the studio tries to automatically connect it to a compute instance. The compute instance provides the necessary compute for interactive exploration within the dashboard. The output of each component you added to the pipeline is reflected in the dashboard. Depending on the component you selected, you can find the following insights in your responsible AI dashboard: error analysis, explanations, counterfactual, causal analysis. Let's explore what we can review for each of these insights. Explore error analysis. A model is expected to make false predictions or errors with the error analysis feature in the responsible AI dashboard. You can review and understand how errors are distributed in your data set. For example, are there specific job groups or cohorts in your data set for which the model makes more false predictions? When you include error analysis, there are two types of visuals you can explore in the responsible AI dashboard. Error tree map. This allows you to explore which combination of subgroups result in the model making more false predictions. Error heat map. This presents a grid overview of the model errors over the scale of 1 or 2 features. So back to the explanation again. So like I said, you can read through this and be like, oh, they're speaking too much grammar, they're speaking too much English or technical, stuff. It's for you to first calm down and look and say, what are we doing really? Why are we exploring error analysis, right? They're telling you that there are two subgroups that we are able to, use to understand this, and that's the error tree map and the error heat map. And as the AI ethics engineer that you qualify to be, to some other people, it might seem like Greek, but your aim is to be able to explain to them like, oh, no, this is not Greek. This is exactly why I wanted us to set up all those dashboards. Why? Because I need to perform all these things for us to see whether our AI is meeting ethical standards. And for us to be ethical, we can always beat our chest and show people that this is what we know about what happened. Exploring error analysis helps us to know, like, are we on track, or why did we get false, predictions? Like, I put in certain data and it's giving me false information. Why? What's going on there? In this case, we are using pregnancy and age to try and explain our error rates. So looking at this, right, you see something like 1058 over 5,000. Tree maps are one of my favorites because they explain things more easily for you to follow along. Forget all the numbers at first that are making you look like what's going on here based on what this error tree map is showing. But if you look carefully, it's just mathematics. I know a lot of us are from various backgrounds, and mathematicians are smiling like, oh yes, I love maths. Or the statisticians are like, yes, I love statistics. And the Pythonistas are like, yes, I love code. It doesn't matter. You can learn these things. It's just for you to understand what's going on happening right here, right? So what you can look, when you first look at all this, notice their color mappings, right? There's this color blue, there's this gray, there's this pinkish, darker pinkish, lighter pinkish. And then notice there's like a branch here, there's a branch there. If you follow this branch,
Okay, good afternoon, everyone. Kindly confirm you can hear me. Okay, so sorry. The facilitator is currently off the call due to some technical or internet issue. Please kindly bear, and in the next few minutes he will join back. Thank you very much. So you can still continue with what he has taught. You can be practicing, and before he joins back. Thank you very much for your patience. Okay, everyone. So before Chooks joins back, if you have any question, you can please drop it in the chat. I can be attending to your questions, and if there are questions I can attend to, when Chooks come back, we can always refer to them. So if you have any question based on what Chooks has taught today, kindly drop the question. Yes, the attendance. Okay, the attendance link has been dropped, so you can always fill the attendance. Don't forget, it is very important for you to complete the attendance. And if you have not been doing it for since the beginning of this class, it is very important to send an email to AI community at data science Nigeria .ai, and then so that the procedure on how to get that done can be shared with you. Okay, I think you is back. Choose, can you hear me?
Yes, I can. Sorry, I didn't know why my network logged me out.
Oh, no problem, no problem.
So I can share my screen again, right? So let me
Yes, we
just
can.
do that. Is my screen shared? Hello? Can you hear me?
Yes, your screen is up. Your screen is up.
Okay. Sorry. I don't know why. I dropped off explaining the tree, right? Did I talk about the 5,000 being broken down to 2430 and 2570, right?
I think you can start with the tree. Let's start from the beginning.
Okay.
Yeah.
All right. Sorry for the break in transmission. So we'll start again from the error tree map. The error tree allows you to explore which combination of subgroups results in model making more false predictions. So following through, like I tried to explain earlier on, this 5,000 can be broken down to 2430 and 2570, right? But notice what's going on here. This is not what we are more interested in. We're more interested in what went wrong, right? So that's why we are following the colored mapping. And from here, we can see pregnancies greater than 1.5. This is just telling you that there are pregnancies that are less than the 1.5. They did not make it to this side. They were on the other side. Going on down the tree again, we get to see there's the blue mark continues towards the side. Then there's another side that is not going to that side. But we're interested in this side. Why? Notice the 532 over 123, 372, 1367. It's showing you that for pregnancies greater than or equal to 5.5. Remember, we started with for pregnancies that were greater than 1.5. That's like the basis. We now got to a point where we're like, even for the ones that were greater, now there's a cap. What we're interested in wasn't just above the 5.5. Once above 5.5, we're not interested in that one anymore. What we're interested in is the pregnancies that were less than. Error tree map is showing us where we should follow, what is causing this error. And then we are like, for pregnancies greater than 1.5, for less than 5.5, we are following down to this. And from here, the other parameter that we finish with the pregnancy that is now influencing what our error is age. Age that is less than or equal to 23. And that means the one that we're interested more in are the ones that were above 23.5. The error tree map shows you exactly, like what we said, a model is expected to make false predictions or errors. With the error analysis feature in the responsible AI dashboard, you can review and understand how errors are distributed in your data set. And that's what this example is here showing you. On a good day, you have just run your model, but as in your data set, you'll be like, oh, I've done well. But without having you as an AI engineer on their team, telling them, no, we've got to check for this. We need to know exactly which part of our data set needs to be checked. That's just what this error tree map is showing. And then, like you said, this error analysis, that there are two types of visuals you can explore in the responsible AI dashboard. This tree map showing the error coverage and the error rates, which is kind of high if you're asking me, like, why should error be 62 points? But at least you now know where and how you can now, focus on what happened and why. So this is remember what we talked our transparency, trust and all those. You understanding this, I've been able to explain it. Perfect. Everybody wants you to be on their team. Let's talk about the error heat map. Like I said, my statistics friends on the call and the mathematicians are smiling because this is their field. Everybody knows this. And some of you that have done data analysis, you too, like, we know this, no shaking. But don't let anything scare you. When you see all these things, everybody can learn it if you really just calm down and take your time. You're the data scientist and it's your field. You got this, right? Error heat map presents a good overview of the body of errors over a scale of 1 or 2 features. On the dashboard, you can see the error rates, pregnancies, feature 1, age, feature 2, binning threshold, on-site binning. There are more resources on Microsoft Learn that you can, for further reading, check up to understand more about this. But just for your own time, the summary of what's going on here, you have your pregnancies being lined up on this axis. These ones are your pregnancies, and you have your age on this axis. different from your normal graph, right? It's your same graph. The only difference is that they put your age up here. Normally, on your normal graph, you have age here, and then your normal graph, pregnancies, you have it over here, right? But so because of space, they just put it like this for you to see, right? The other different thing from your normal map is that your normal map have normal numbers. This one is giving you two numbers, comma, comma. Are you in trouble? No, it's just showing you the distribution as well. So it's telling you like, for example, this place is age 20.9. Of course, nobody has 0.9, but if you calculate your months, you can add 0.9 to your age. So if you say you're born in whatever, but let's look at the first age. This person is just 20 years old. For 20 years old to 28, this is where they are. For 28 to 35, this is where they are. 35 to 42. So when you break it down like that, it becomes more easier for you to understand what's going on, right? So for 70 to 77-year-old, that's what just what's going on right here. This is just telling you how much, instead of just one age, over this distribution of 20 to 28, that's what's going on here. Same thing on this axis, the pregnancies. I've not been pregnant before, so I don't really know how to measure pregnancies in these terms, but you should understand when they are telling you that minus 140, that means maybe it has happened, but we are not seeing it, but it's there, okay? Women should pardon me for that, but it's there, right? There's 1.75, there's 3.5. Within that range, something's happening. We are seeing something, right? Something's happening. 3.5 to 5.2. So I'm guessing like 5 months or trimester. I think I've read that word before. So 5.25, 7.0, 7.0, 8.7. So it's increasing, showing you the distribution between the pregnancy calculation. That is what's going on. So when you understand what's going on right here as pregnancies increase and as age increases, now you can now use to understand what's happening with our error analysis. Remember, you're the AI dashboard engineer or scientist breaking this thing down with them. So you now, once you understand what's going on, you can become a superhero, like I told you that you are already, to explain to them that, okay, you see where we're having this 100%, there's problem. That's where the error is. So for the age group bracket and the pregnancies of this, there was 100% wrong answers or wrong predictions or what's going on there. So there's five amount, but where there was 0, 0, 0, maybe that was good. But how come we're having 0, 0 and then 100, 0, 100 over this particular age gap? What should we study here? That maybe as we progress in pregnancy, there was 0, but as we got above this particular month or metric, say having 100 again, fluctuation. So something's going on right here between this band. And then notice also the color range that they're giving you. The gray ones out are 0%. The darker colors and the deeper colors are 100. So those are things you should notice and use that to understand your error analysis. And because of time, we have to jump forward again. There are more things we check. So like I said, we've done the error analysis. You can also use the explanations. Whenever you use a model for decision making, you want to understand how a model reaches a certain prediction. Whenever you find a model that is too complex to understand, you can run model explainers to calculate the feature importance. In other words, you want to understand how each of the input features influences the model's prediction. There are various statistical techniques you can use as a model explainer. Most commonly is the mimic explainer trains a simple interpretive model on the same data and tags. As a result, you can explore two types of feature importance. Aggregate feature importance shows how each feature in the test data influences the model's predictions overall. Aggregates. So what simply telling you is like, you can either do the aggregate feature importance. I'm just going to rush a bit further here. I can also do individual feature importance. The difference between both, while this one focus on all data, because it's the same diagram of just while this focus on all data, this one focuses on a selective part on just we are zooming in more. So you can see the feature importance, average of absolute value. This is aggregate feature importance. And then it raised based on which, like the one we saw above, what pregnancies had the effect of error, followed by age, followed by BMI, followed by the serum insulin. But when we narrowed it down to the individual, it was like age played a major role instead, the plasma glucose, tricep thickness, and the serum insulin. So your own job is to understand and use all this. This one should be much easier than the tree map and the heat map. The counterfactuals. Explanations can give you insight into relative importance of features on the model's prediction. Sometimes you may want to take it a step further and understand whether the model's predictions would change if the input would be different. To explore how the model's output would change based on a change in the input, you can use counterfactuals. You can choose to explore counterfactuals what-if examples by selecting a data point and decide model's prediction for that point. When you create a what-if counterfactual, the dashboard opens a panel to help you understand which input will result in the desired prediction. So this one is a bit straightforward. A counterfactual is more, what if I change this input? What will affect the output? And it's a normal life situation where we unconsciously we do sometimes, like, maybe you're selling, let's use a normal business, buy and sell, you're selling shoes, and I don't know, that was a good example. But you're just picking something that you already know that you're familiar with. And then you ask yourself, what if I change this thing? What will happen? So that's what counterfactuals just simply mean. It's more of like, what if I change the input? What will affect my model? Will it be much or will it be less? So it's something you can quickly run out to. I noticed you didn't really put much of diagrams regarding that. Causal analysis. Like I talked about the cause and effect issue, why you need to do this. Explanations and counterfactuals help you to understand the model's predictions and the effects of features on the predictions. So the model interpretability may already be a goal by itself. You may also need more information to help you improve decision making. Causal analysis uses statistical techniques to estimate the average effect of a feature on a desired prediction. It analyzes how certain interventions or treatments may result in a better outcome across the population of a specific individual. There are 3 available tabs in the Responsible AI dashboard when including causal analysis. The aggregate causal effects. This shows the average causal effects for redefined treatment features, the features you want to change to optimize the model's predictions. The individual causal effects shows individual data points and allows you to change the treatment features to explore their influence on the prediction. And the treatment policy shows which parts of your data points benefit most from a treatment. Because of time, we could just jump on to the next map. But this is all for the Responsible AI dashboard that in our create and explore the Responsible AI dashboard for a model in Azure machine learning. And yeah, if we were able to go through the introduction, Responsible AI, create Responsible AI dashboard, evaluate the Responsible AI dashboard. And in your own spare time, you can go through this as well, another check and exploring the Responsible AI dashboard. So we are on to the final lab, which is deploy and consume models with Azure machine learning. Yeah, let's go into that. Let's deploy and consume models with Azure machine learning, and we see how to cover 2 modules. So we have to be a bit fast. We're going to the first. Okay. Imagine you train the model to recommend restaurants. The model has been trained and tracked in Azure machine learning. You want to use the model in your application where consumers can browse restaurants in their area. Each time a consumer selects a restaurant in the application, you want the model to recommend other restaurants that might also be of interest to the consumer to improve the user experience. Whenever you train a model, you ultimately want to consume the model. You want to use the trained model to predict labels for new data on which the model hasn't been trained. To consume the model, you need to deploy it. One way to deploy a model is to integrate it with a service that allows applications to request instant or real-time predictions for individual or small sets of data. endpoints. The example being given here is that we want to deploy our model, right? And we need to satisfy certain instances that you want to consume the model when we deploy. And we dig labels for new data which the model hasn't been trained. Anytime I don't know whether I can mention any recommending platform, your Google Map or even Netflix, what they are doing is the AI sees what we like, and in real time, it sends information back, and the model is, we want to test that new data that as in based on what we watched or based on what we liked, either on the Google Map or on the Netflix or any of the other services that in real time, it's predicting to us, okay, you like this movie, maybe you like this other movie. You like Chinese film, maybe I should recommend another Chinese film for you. All this is happening in real time, and that's just all what's going on in here. It's based on the consumption of when we deploy and manage to an online endpoint. That's all what's going on in here. We, the user, when we use it, it comes back, it goes in, it needs to be tested, retrained again with the new inputs that we are giving it. So that's what they're just trying to break down in here. And in this line of objectives to create managed online endpoints. So is that endpoint that what happens when someone is sending in new data to our model? How is it going to be sent? And what's the process that really goes in? So that's what we are going to be doing in this module. Then to deploy your MLflow model to manage online endpoint, deploy a custom model to manage online endpoint, and then to test the online endpoint. To make a machine learning model available for other applications, you can deploy the model to a managed online endpoint. You learn how to use managed online endpoints for real-time predictions. To get real-time predictions, you can deploy a model to an endpoint. An endpoint is an HTTPS endpoint to which you can send data and which will return a response almost immediately. Any data you send to the endpoint will serve as the input for the scoring script hosted on the endpoint. The scoring script loads the trained model to predict the label for the new input data, which is also called inferencing. The label is then part of the output that return. So there's like a flow from inputs to outputs. That output is becoming, the endpoint. That endpoint being inputted again with the scoring script that new data is being inputted. That scoring script itself, loads the trained model to predict the label for the new input data. That inferencing is all what's going on. The label is then part of the output that's returned back again. So it's a continuous process, and that's what goes on when you are using your Google Map and you're stuck in traffic. You're like, oh, I'm at Yaba, and I inputted like, okay, I want to know what's going on. In real time, your Google Map is showing you where the red flags are and everything. But in minutes, if you were to check it again, you've already given it new data, it sends it back again and it sends it back to you. So that's real time. You see how the traffic flow changes, even especially if you're maybe in a bus and you're in hold up and you're moving. You notice how this influencing is moving. It's based on your mobile phone location, sending information to Google. And Google is constantly doing this. It's taking that new input from your location and sending it. That location you are looking for, someone else might need it, and it's sending it back to train the model to send to other people that, oh, there's traffic in Ojuelegba, oh, there's traffic in Oyibo, so take another route. That's all what's going on right there. That's all the grammar that is being spoken about there. Within Azure Machine Learning, there are two types of online endpoints. The managed online endpoints, Azure Machine Learning manages all the underlying infrastructure. The easy way that I tell you that no code kind of, you just give Azure Machine Learning managed online endpoint, that you do it for you. And then there's the Kubernetes online endpoint. Users manage the Kubernetes cluster, which provides the necessary infrastructure. And because you're a superhero, you're a Pythonista, you're a superhero, you're going to be doing most of this one. Well, at least you must understand it, even if you want to use the easy way. Still know how to do the manual and the other side. You could allow Azure Machine Learning and do everything for you, which is fine. But at least you must understand what's going on. As a data scientist, you may prefer to work with managed online endpoints to test whether your model works as expected when deployed. If a Kubernetes online endpoint is required for control and scalability, it likely be managed by other teams. So they're telling you like this data science that we're in is made up of a lot of skills and a lot of people. So there are the data architects, there's the engineers, there are a lot of people. So like when we're dealing with this, we might need more people on the team that you might just be just if you might just be focused on just managing the online endpoints. But you need to understand what's going on so that when you're part of the team, you know what other people in the team are doing and you can always key in. If you're using a managed online endpoint, you only need to specify the virtual machine type and scaling settings. Everything else, such as provisioning compute power and updating the host operating system, is done for you automatically. So life is made easy with that. So deploy your model. After you create an endpoint in the Azure machine learning workspace, you can deploy a model to the endpoint. To deploy your model to a managed online endpoint, you need to specify 4 things: your model assets, your scoring scripts, your environment, and your complete configuration. Because of time, you can read that more on your own, but let's jump on to all of these elements are defined in the deployment. The deployment is essentially a set of resources needed to host the model that performs the actual inferencing. Excuse me. Blue-green deployments. One endpoint can have multiple deployments. One approach is the blue-green deployment. Let's take the example of the restaurant recommender model. After experimentation, you select the best performing model. You use the blue deployment for the first version of the model. As new data is collected, the model can be retrained and a new version is registered in the Azure machine learning workplace. To test a new model, you can use the green deployment for the second version of the model. So remember when I talked about maybe having like a 90% train and then a 10% test? It's similar happening here, but what's going on here? We are using colors to try to experiment our deployment. So it's almost like an A/B testing for those of you that are social media managers. A/B testing where you send up to find out which one is the best one to use. So you try A and you try a B, and then you set two of them out, and then you come back. Which of you brought back more money, A or B? If B brought in more money, why am I wasting time with A? I beg, let's do B. But if you not send two of them out, you're not able to know which one is the best one to do. So in this case, our AB is blue-green. And what it's talking about here is like, let's take the example of the restaurant recommender model. After experimentation, you select the best performing model. You use the blue deployment for the first version. So you say, let's use blue, right? As new data is collected, the model can be retrained, and a new version is registered in the Azure machine learning workplace to test the new model. To test a new model, you can use the green deployment. So the first one was blue. We got new data. Then we now retrained it. So the new one we got to test the new model, you can use the green deployment for the second version of the model. Both versions of the model are deployed to the same endpoint. So now, using that our Google Map example, because I think that's a simpler explanation. It's more complex than that, but I just wanted something that most of us use in traffic, since we are used to traffic, is that our endpoint is like all of us with our phones, right? Both versions of this model are deployed to the same endpoint. So we are like the endpoint in this scenario, which is integrated with the application. Within the application, the user selects a restaurant, sending a request to the endpoint to get new real-time recommendations of other restaurants the user may like. As you're engaging with this one, they're using the restaurant. As you're engaging with the app, the restaurant is able to, based on your formal request, it has been retrained and sends you the new updated model, which you now engage with. And then it's able to recommend to you like, oh, based on the formal input you gave, have you considered this other restaurant? Same with our Google Map illustration of if you're driving in your car and showing you there was traffic at Ojuelegba, and then you were about to take a next turn, but it showed you that, but if you go on for the next 10 minutes and take a left turn, this other place is going on. You refuse to follow that instruction. You take another turn, and then we are rearranging itself and tells you, based on your strong head, I found you a better route. So it calculates based on what you're giving it. So the feedback of input output is happening simultaneously in real time. When a request is sent to the endpoint, 90% of the traffic can go to the blue deployment, and 10% of traffic can go to the green deployment. With two versions of the model deployed on the same endpoint, you can easily test the model After testing, you can also seamlessly transition to the new version of the model by redirecting 90% of the traffic to the green deployment. If it turns out that the new version doesn't perform better, you can actually go back to the first version of the model by redirecting most of the traffic back to the blue deployment. This is simply telling you that even though we are sending out both the blue and the green deployment, we give one more traffic. In this case, we are giving the blue more. And then we give the other, the green, less. But when we send it out, and then we're now realizing that the people's feedback, they are preferring that green, lesser traffic we gave it. Then be like, you know what? Let's switch to the green. So we now switch the traffic of 90 that we gave the first one. We now switch it to the green and give the blue back 10. And we can always roll back if eventually people start liking the blue more than the green, because it's a continual process of input, output. Blue-green deployment allows for multiple models to be deployed to an endpoint. You can decide how much traffic to forward to each deployed model. This way, you can switch to a new version of the model without interrupting service to the consumer. Read more on that. To create an online endpoint, you use the managed online endpoint class. Okay, now this is talking about our code. And remember what I said about code? It's our superpower. We need to understand how this works. Name of the endpoint must be unique in the Azure region. Authentic mode, use key for key-based authentication. Use AML token for Azure machine learning token-based authentication. To create an endpoint, use the following command. For Azure.ai.ml entities, import managed online endpoint. Create an online endpoint. That's what this is showing you here. Endpoint, managed online endpoint, name, endpoint, description, online endpoint, authentication mode, key. ML client begin create update endpoint. The result. Always notice we are repeating this again and again. Very important to note all these things that we use. So next point. Deploy your MLflow model to a managed online endpoint. The easiest way to deploy a model to an online endpoint is use an MLflow model and deploy it to a managed online endpoint. Azure Machine Learning will automatically generate the scoring script and environment for your MLflow models. To deploy an MLflow model, you need to have created an endpoint. Then you can deploy the model to the endpoint. Deploy an MLflow model to an endpoint. When you deploy an MLflow model to a managed online endpoint, you don't need to have the scoring script and environment. To deploy an MLflow model, you must have model files stored on the local path of the registered model. You can log model files when training the model by using MLflow tracking. In this example, we're taking the model files from the local path. The files are also in the local folder called model. The folder must include the ML model file, which describes how the model can be loaded and used. Next to the model, you also need to specify the compute configuration for the deployment. Instance type, virtual machine size to use, instance count, number of instances to use, and more code. In your spare time, please go through this, because I want to also, like I said, reach out to parts that we might need more understanding. Since only one model is deployed to the endpoint, you want this model to take 100% of the traffic. So in this case, we're not using blue and green, it's just one. And so we're giving it all the 100% of the traffic. When you deploy multiple models to the same endpoint, you can distribute the traffic among the deployed models. To route traffic to a specific deployment, use the following code. So this is show you how we route traffic. If there was the green one, the green would have been blue 90, green 10. So understand the code, like I said, that's all what's going on here. To delete the endpoint and all associated deployments, run the command ML client online endpoints begin delete endpoint. Understand the code as a superpower Pythonista. Back here, deploy a model to a managed online endpoint. You can choose to deploy a model to a managed online endpoint without using the MLflow model format. To deploy a model, you need to create the scoring script and define the environment necessary during inferencing. To deploy a model, you need to have created an endpoint, then you can deploy the model to the endpoint. To deploy a model, you must have model files stored on a local path or registered model, a scoring script, and execution environment. The model files can be logged and stored when you train the model. So it's almost like we are repeating this. We've said most of this in the beginning. Why importance of scoring script? The scoring script needs to include two functions. The init, that which is called when the service is initialized. The run is called when new data is submitted to the service. The init function is called when the deployment is created or updated. Remember when I told you, remember that created or updated, that's what's happening. To load and cache the model from the model registry. The run function is called for every time the endpoint is invoked to generate predictions from the input data. The following example Python script shows this pattern. So in your spare time again, try to understand what's going on in the code. Like I said, it's just simple. Don't let it scare you. Create an environment. Your deployment requires an execution environment in which to run the scoring script. You can create an environment with Docker image, with conda dependencies, or with a Docker file. You create an environment using a base Docker image, you can define the conda dependencies in a conda.yml file. And yes, this is kind of straightforward for you to see what a environment looks like. Then to create an environment, run the following code. From the entities import environment, and then we use this file we created here, and we points to it. Environment created from Docker image plus conda environment. The YAML file is right here, the conda file. So like I said, try and understand what's happening in the code. And notice this again, create or update. Always just notice those simple things. Create the deployment. When you have the model, scoring script, and environment, you can create the deployment. To deploy a model to an endpoint, you can specify the compute configuration with 2 parameters, instance type and instance count. To deploy your model, use the manage online deployment class and run the following command. Again, our Python codes for our SDK. You can deploy multiple models to an endpoint. To route traffic to a specific deployment, use the following code. Remember, we talked about this earlier on, still the same blue, but if you add multiple ones like green, you can share it as well. And to end, same end. So then so the next one, only difference itself is that, okay, after the test manage online endpoint, after deploying a real-time service, you can consume it from client application to predict labels for new data cases. Meaning like once we've created what we want, you can just quickly test it. You can list all endpoints in the Azure Machine Learning Studio by navigating to the endpoint space in the real-time endpoints tab. All endpoints are shown. You can select an endpoint to review its details and deployment logs. Additionally, you can use the studio to test the endpoint. So if we are to go through to test, this is what you see in the folder of, remember our map when we did our tree map and our aggregated map, all the things that were, the columns that were affecting us, pregnancies, plasma glucose, they're all listed here under this input data. So once we deploy, we can always use this to find out what's going on and how to do that. So this is just showing you how we can test our results to see whether what we are doing is working. For testing, you can also use the Azure Machine Learning Python SDK to go an endpoint. Typically, you can send data to deploy models in JSON format with the following structure. And yes. So we are done with this one, but we still have one more model. This last model is similar to what we just went through. The difference now, we are talking about batch inferencing. The other one we were talking about was just one. So it's actually the same thing, but we're now doing it as regarding batch. So it's just for you to go through on your own. It's similar to what I just put you through. Since you already have the foundation of what I just put you through, it's just similar. But instead of using single, we're talking about batch predictions. You can deploy a model to an endpoint, and HTTPS. It's similar to what we just talked about already. But I'm trying to find out if there's anything that might be a bit different, apart from it being batch job. Okay, you use compute clusters for batch deployment. The ideal compute to use for batch deployment is the Azure Machine Learning Compute Cluster. If you want the batch scoring job to process new data in parallel batches, you need to provision a compute cluster with more than one maximum instance. To create a compute cluster, you can use the AML compute class, which is shown down there in the code. Sorry, I have to run because of the time. I don't want to keep you guys more than this. An easy way to deploy a model to batch endpoint uses an MLflow model as well machine learning with automatically generates currently. Like I said, we already talked about this. You can do it the automatic way by just using the MLflow model. But to deploy an MLflow model, you need to have created an endpoint. Then you can deploy the model to the endpoint. To avoid needed a scoring script and environment. An MLflow model needs to be registered in the Azure machine learning workspace before you can deploy it to the batch endpoint. So this is just showing you how to do all that. I'm looking for okay, this might be interesting. When you configure the model deployment, you can specify instance count, max concurrency per instance, minimum batch size, output action, output file name. more codes. I could still come back to them, but let us go through to find out. If you want to deploy a model to a batch endpoint without using the ML flow model format, you need to create a scoring script and environment. To deploy a model, you must already create an endpoint, then you can deploy the model to the endpoint. The scoring script is a file that reads the new data, loads the model, and performs the scoring. The scoring script must include two functions: the init, all the ones at the beginning of the process, and the run, also for each minute batch to perform the scoring. The run method should return a pandas data frame for an array or list. A scoring script will look as follows. So basically, most of what is happening here is similar to what we just covered in the last module. The only difference now is we are configuring it for a batch. And because I don't want to take too much time, that's what I'm running through for you to find out just the little differences between what we did in the past and what we are doing here now. And yeah, when you invoke a batch endpoint, you trigger an Azure machine learning pipeline job. The job will expect an input parameter pointing to the data set you want to score. Trigger the batch scoring job. To prepare data for batch predictions, you can register a folder as a data set in the Azure machine learning workspace. You can then use the registered data asset as input when invoking the batch endpoint with the Python SDK. So that's what this code is just in here trying to explain. You can monitor the run of the pipeline job in the Azure Machine Learning Studio. All jobs that are triggered by invoking the batch endpoint show in the jobs tab of the batch endpoint. The predictions will be stored in the default data store. So here we can see status, completed fields, fields completed, detailed jobs, and troubleshoot a batch scoring job. The batch scoring job runs as a pipeline job. If you want to troubleshoot the pipeline job, you can review details and the outputs and logs of the pipeline job itself. So remember when we talk about pipelines, right? You're already familiar with this, so you should be comfortable seeing when you see this. This is just showing you other child jobs that completed or didn't. And yes. So with this, we come to the end. If you want to troubleshoot the scoring script, you can select the child job and review its outputs and log. Navigate to the output plus logs tab. The log user folder contains 3 files that will help you troubleshoot. Job error.txt, job progress, the overview, the text, job result. So yeah, you'll find all this when you want to troubleshoot, all labeled under the user folder. So I know I ran through the last module, but trust me, if you understood what I did in the first module, you can just, flow with all this. And I apologize once again for the glitches, the network, and the other problems we faced. And I hope I was able to deliver, and some of you are more confident in, taking the DP100. So thank you, Tejumola. Thank you, JSN, for the opportunity to share. And yes.
Thank you very much, Chooks. Kindly confirm you can hear me. Yeah, so we are very grateful for this your time on this call, and then I'm very sure that everyone on this call have learned, and then we should be able to deploy this. Now, this is a trick. Do make sure you practice, and then if you are now facing any issue, Chooks is ready. Also, Emmanuel is available to put you through. We also have a lot of certified associate Azure for machine learning associate that can put you through on this. So please do well to practice so that when you encounter any issue, any error, any bug, you can always escalate, and our facilitators and mentors will be available to attend to you. So we can continue this conversation on our Telegram group, which is very important. And if tomorrow is going to be another day, and that's the last day for Azure for machine learning, I'm sure some of us will be excited that tomorrow is the last day for the 5 days Azure for machine learning. Okay, good. So let's be punctual. Let's join very early. I noticed a lot of people joined late today. Join very early, and then I promise you there's going to be an awesome session as usual. So thank you everyone for joining. Do well to fill the attendance form. The attendance link has been dropped separately. So do well to fill the attendance form, and then yeah. And so thank you very much. and then do enjoy the rest of your day. Okay, bye.